Now we move on to the next concept, that is finding the angles between the two planes. This is just similar to finding the angle between two lines. If you want to find the angle between two lines, we just take the cos theta equals to dot product of its direction ratios upon modulus of the direction ratio. So here also we just take the dot product of the normal of the plane and the dividing by the magnitude of the normal of the plane. That is, cos theta is given by n1 dot n2 upon modulus of n1 modulus of n2. In the Cartesian form it is also similar. If the equation is a1x plus b1y plus c1z equals to d1 and a2x plus b2y plus c2z equals to d2, then cos theta, the angle is given by a1a2 plus b1b2 plus c1c2 upon under root of a1 square plus b1 square plus c1 square under root of a2 square plus b2 square is plus c2 square. Similar to what we do in the line. So if you want to find the angle between two planes, just similar to finding the angle between two lines. Just substitute the values in the given formula and we will get the angle. Now here we can also see there can be conditions also. So what are the conditions? The conditions can be if two planes are perpendicular. Then if two planes are perpendicular, then cos theta, the theta will be equals to 90 degree. So the condition will be similar to line, that is n1 dot n2 equals to 0. So that means we can always write a1 a2 plus b1 b2 plus c1 c2 equals to 0. And if the two planes are parallel, that means the direction ratios of normal are proportional. That means if theta equals to 0 degree, then what will be the condition? It will be a1 by a2 equals to b1 by b2 equals to c1 by c2. That means the direction ratios of normal are proportional. So these are the conditions for perpendicularity and parallelism. So for perpendicularity it is a1 a2 plus b1 b2 plus c1 c2 equals to 0, and for parallelism it is a1 by a2 plus equals to b1 by b2 equals to c1 by c2. So for parallel, the direction ratios of normal should be proportional. For perpendicular, the dot product should be equals to 0. Just similar to line. In the line we take the direction ratios of the line. Here we take the direction ratios of the normal. Now we will see a typical problem on the equations of plane. So this is a kind of problem which you will be asked in your examination, and this is a kind of a typical problem on a plane. But if we understand the concept, then it will be very easy for us. You have to find the equation of the plane through the points 2, 1, minus 1 and minus 1, 3, 4, and it is perpendicular to the plane x minus 2y plus 4z equals to 10. And we have to also show that the plane so obtained contains this line. So seems quite difficult. But now what we'll do is we'll solve this question step by step. So first we need to know that we'll always, if we want to consider the equation of a plane, we'll consider the basic equation, the most important one, that is given by a x minus x1 plus b y minus y1 plus c z minus z1 equals to 0. So this is the equation of plane. So this is the equation of the plane we have considered. We are given 2 points. So the first point is x, 2, 1 and minus 1. So we can replace this point here. So I will get a x minus 2 plus b y minus 1 plus c z plus 1 equals to 0. Now this plane also passes through the point minus 1, 3, 4. So that means this point will satisfy this equation. So in place of x, y and z, can we not substitute this point? So what we'll get is, if I substitute this point, I'll get a, the value of x will be minus 1 minus 2 plus b 3 minus 1 plus c 4 plus 1 equals to 0. So thus we get the equation as minus 3a plus 2b plus 5c equals to 0. So this is the first equation. We need to solve the equations to find the values of a, b and c. This is the first equation we get. Now the given plane is also perpendicular to the plane x minus 2y plus 4z equals to 10. So if it is perpendicular to this plane, that means the dot product of the direction ratios of their normals is equals to 0. So that means the direction ratios of this plane will be, so if the plane is x minus 2y plus 4z equals to 10. Its direction ratios are 1, minus 2, 4. And the direction ratios of the plane which we have considered is A, B and C. The second equation will be 1 into A minus 2 into B plus 4 into C equals to 0. That is A minus 2B plus 4C equals to 0. So this is the second equation. The dot product of the normal vectors of both the plane is equals to 0 because these two planes are perpendicular. Now we have two equations. Can we not solve them to find the values of A, B and C? When this is equals to 0, we will solve it by the method of cross multiplication. So by solving A, B and C, we will get the value of A, B, C as A upon, we will multiply the B and C coefficient. 2 4s are 8 minus 5 2s are 10 minus 10. So 8, 4 2s are 8, that will be 4 into 2 minus 10. 5 2s are 10, which is with the negative sign, equals to minus B upon, we will multiply A and C. This is just like solving the determinant. Minus 3 into 4, that is minus 12, and 5 into 1, that is given by minus 5, and which is equals to C upon, we will just multiply A and B, that is minus 3 into minus 2 will be 6, and minus 2 into 1 will be 2. So we will get the value as A upon 18 equals to B upon minus 17, C upon 4. So B and B will get cancelled. So we get the value of A as 18 lambda, can be any multiple, B as 17 lambda and C as 4 lambda. So these are the values of A, B and C. So we can substitute these values in the equation and we'll definitely get the equation of the plane. So we'll substitute these values to find the equation of the plane. So by solving those equations, we have got the value of A, B and C as 18 lambda, 17 lambda and 4 lambda. We just substitute those values in the given equation, the equation of the plane, because we only needed to find A, B and C. So if substitute those values, we can remove lambda from here because lambda can be any multiple. It is equals to 0, it will not be considered there. So we'll just substitute A as 18, B as 17 and C as 4, and we get the equation of the plane as 18x plus 17y plus 4z equals to 49. This is the first thing we need to find. We need to find the equation of the plane. So we have got the equation of the plane as 18x plus 17y plus 4z equals to 49. The next question is, we have to show that the plane so obtained contains this line. This line is minus I cap plus 3j cap plus 4k cap plus lambda 3i cap minus 2j cap minus 5k cap. So our first step is we need to convert this equation to the Cartesian form. So to convert the equation to the Cartesian form, the equation of line will become x plus 1 upon 3 equals to y minus 3 upon minus 2 equals to z minus 4 upon minus 5. We have already discussed line. We know how to convert this equation to the Cartesian form. So we have converted this. Now if the plane contains the line this, that means the point through which the line is passing is also passing through this plane. We can also see a rough figure. Suppose there is a plane like this, right, and there is a line on this. So that means if there is a point on the line, if that point satisfies the equation of the line, that means it will also satisfy the equation of the plane. So that means the point here is minus 1 comma 3 comma 4, and that should satisfy the equation of the plane. So if I substitute this value here, 18 minus 1 plus 17 into 3 plus 4 into 4. If I solve this, it should be minus 18 plus 51 plus 16. So if I'm solving this, I'm getting the value as 49. That means the point minus 1 comma 3 comma 4 is satisfying the equation of the plane. So that means this plane contains this line, because point minus 1 comma 3 comma 4 is satisfying the equation of the plane. That means the plane is containing that line. So this is how we go about solving this problem. The problem looks difficult, but it's not that difficult. So what we need to do is, we need to consider the basic equation of the plane, that is ax minus x1 plus by minus y1 plus cz minus z1 equals to 0. You know one point and we substitute ax minus 2 plus by minus 1 plus cz plus 1 equals to 0. The next step, we need to find a, b and c. For finding a, b and c, we need at least two conditions. So the first condition is it is passing through the point -1, 3, 4. So I've substituted those values here and I've got an equation. So x, y, z, in place of x, y, z we put -1, 3 and 4. And it is also perpendicular to the plane x minus 2y plus 4z equals to 10. That means the direction ratios of the normal of this plane and the direction ratio of the normal of the plane which we need to find the equation of, the dot product is 0. That is a into 1 minus 2 into b plus 4 into c is equals to 0. We solve those equations with cross multiplication method and find the values of a, b and c. Substitute those values in the equation, we get the equation of the plane. If I need it in vector form, I can also convert it into vector form. Next step is we need to show that it contains the line this. So for this line, we need to convert the equation always to Cartesian form. You need to keep this thing in mind that Cartesian form solving is very easy. So we convert it into Cartesian form and we find that the point is -1, 3, 4. Substitute that point in the equation of the plane and we solve the equation and we know that the equation of plane is satisfied by that point. So we get equals to 49. So that means this plane contains the line which is given by the equation. Now we'll discuss one more problem on plane which is just similar to the previous problem. We'll just see how we go about solving the problem. Now this is very similar to the previous problem, but the conditions are different. You have to find the equation of the plane which is passing through the point 1, -1, 2 and perpendicular to each of the planes 2x plus 3y minus 2z equals to 5 and x plus 2y minus 3z equals to 8. So this is the plane from which the equation is need to be found out. So the first step we need to do is we need to consider the equation of the plane as the basic one. So the equation of plane will be a x minus x1, x1 is here 1 plus b y minus y1, y1 is here -1, so y plus 1 plus c z minus z1, z minus z1 is here 2 equals to 0. So this is the point x1, y1 and z1 from which the plane is passing. Now the next step is we need to find the values of a, b and c using the given condition. As the plane is perpendicular to both these planes, so we can get the two equations, because the dot product of the normal, the direction ratios of normal of both the planes will be equals to 0. So I'll take this, these are the direction ratios of the first plane, that is 2, -1 and 3. So plane 1, the drs of normal are 2, 3 and -2. So the direction ratios of this plane are a, b and c. So the equation becomes 2a plus 3b minus 2c equals to 0. Similarly, we can consider it for plane 2. So for the plane 2, the drs are, it will be 1, 2 and -3. So the equation becomes a plus 2b minus 3c equals to 0. So this is equation 1, this is the equation 2. Now we can readily easily solve these two equations to find the values of a, b and c. So that will be a upon multiplying the b and c. So 3 into 3, that is -9 and minus 2 into 2 that is 4. So that is 3 3s are 9, -9 and minus 4 will be +4. So -9 plus 4 will be -5 equals to -b upon it will be multiplying a and c. So 3 2s are -6 and minus of -2 into 1, that is -6 plus 2, which will be equals to -4, which will be equals to c upon, which will be multiplication of a and b. So 2 2s are 4 minus 3, that is 1. So 4 minus 3, that is 1. Again we will see that a multiplying b and c, 3 into -3, that is -9 and 2 into -2, that is -4. -9 minus 4 will be -9 plus 4, which is equals to -5. Then b we multiplying a and c. So 2 into -3 will be -6 and -2 into 1 will be -2. So -6 plus 2 will be -4. Similarly for c we will do that, c upon a 2 into 2 4 minus 3 into 1 3. So 4 minus 3, that is 1. So we've got the direction ratio. We can equate it to lambda and we always get the values of a, b and c. So a will be equals to -5 lambda, b will be equals to 4 lambda and c will be equals to lambda. So if we substitute these values here, we get the equation of the plane. So substituting these values in this equation, we'll get the equation of plane as, I'll substitute in place of a, I'll substitute it as minus 5 x minus 1 and plus 4 y plus 1 and plus 1 z minus 2, which is equals to 0. So the equation of the plane will be given by minus 5x plus 4y, minus 5x plus 4y plus z, and minus 5 into minus 1 will be plus 5 plus 4, 9, and minus 2, 9 minus 2 is 7. So plus 7 equals to 0. So this is the equation of the plane which we need to find out. This is the given equation of the plane, that is given by minus 5x plus 4y plus z plus 7 equals to 0. So this is the equation of the plane which is need to be found out. So this is how we solve problems on equation of plane.